Okay, so in chapter 5, we were studying how to solve a linear equations by using linear programming. For instance, you can see, let's say we were given some objective function p equals to 2x plus 5y, and then we were given some constraints, let's say x plus y less than 2, x minus y less than 1. So what we were doing, and x greater than 0, y greater than 0, these were the constraints which are by default understood that x is greater than 0 and y is greater than 0. Then what we were doing, we were plotting these four equations on a same graph paper. We were plotting these four equations on a same graph paper, and then we were trying to analyze the feasible region like this, and we were saying these are the corner points. But now what happens if we have more than four equations? Like now we have four equations and it is easy to deal with four equations. Let's say I write x plus y less than 2, 2xy minus y less than 0, x plus y, x plus y less than 1, x minus y less than 2. If you have 4, 5, 6 equations, then it would be a mess if you draw all those constraints on a same graph paper like this. It would be very difficult for us to figure out the feasible region. So to avoid this difficulty, there is a new method which is called simplex method, which is called simplex method, chapter 6, section 6.1. In simplex method, what we do, we write our all the constraints in general form. For example, here we write, you are given a objective function, let's say c1 x1, c2 x2, it continues cn and xn. Like if you are given any number of equations, if we have n variables, no problem, subject to the following constraints, let's say a1 x1, a2 x2 up till an xn less than equals to b. If all the constants are in this form means to say that this symbol should be less than form. Then we say that you are given standard maximization problem. In that case, we say that you are given a standard maximization problem. So for example, I can give you some example. Let's say you are given an objective function, let's say z equals to 5x plus 10y, and the constraints are, let's say 8x 8y less than 160, 4x 12y less than 180, and of course built-in constraints, x should be greater than 0 and y should be greater than 0. Now this is the standard maximization problem. You see, we have one objective function and all the constraints are in less than form. All the constraints are in less than form except these two constraints. So this is the standard maximization problem. Now we want to solve this standard maximization problem. Normally what we used to do, we plot all the constraints. That is what we did in chapter 5. We put them equals to 0 and we plot them and we find their feasible region. But now, and when we used to do this, for example, if I solve this problem in that manner, it would be like this. This would be their feasible region. That is what we used to do in chapter 5. But now we want to apply simplex method. And if we want to apply simplex method, in simplex method, what we do, we want to maximize our function, and our constraints are 8x, 8y less than 160. This is our first constraint. 4x plus 12y less than 180. Now, if you see this first equation, this left hand side is less than 160. So I want to make them equal. I want to make them equal. So I add some variable s1 and I say that now they are equal. Like 4 is less than 5. And I want to add something here, then they will be equal because this side is less than right side. So in the left side, I need to add something. When I will add, then they will be equal. I don't know what should I add. So this A, I need to find out that what should I add so that these two sides should be equals to each other. Similarly here, if you see this equation, this left side is less than right side. So I need to add something. I said it is a slack variable, slack 1, s1. We call it slack variable. We add slack variable s1 so that now they are equal. Likewise, this second equation, 4x plus 12y plus s2, now they are equal. Understand? So I add some variable to make them equal. They are called slack variable because they take up the slack between the left and right hand sides of the inequality. And also note that the slack variables must be non-negative. I will explain it later that what does it mean that slack variables must be non-negative. Okay, so now we have two equations in four unknowns. You can see equation 3 and equation 4. These two equations with four unknowns. What are those four unknowns? X, Y, S1 and S2. These four unknowns, the system has now infinite number of solutions. As you know, when number of equations, the number of variables are not same. In that case, we have infinite many solutions. Likewise here, the system has infinite number of solutions since there are more unknowns than equations. We can make the system have a unique solution by assigning two of the variable of value 0 and then solving the remaining two variables. This is called the basic solution. For instance, I say x is 0, y is 0, I will get s1 equals to 160. Here, if I say x is 0, y is 0, I can get s2 equals to 180. This is called basic solution. We select any two of the four variables as basic variable, the remaining two variables automatically become non-basic. So how to identify which one would be our basic variable and which one would be our non-basic variable? So I will explain it 0, and we assign the non-basic variable always assign a value 0. Don't forget it. Non-basic variable always assigned a value 0, non-basic variable, right? Okay. So here we say that our non-basic variables are x and y. If non-basic variables are x and y, then s1 would be 160 and s2 would be 180. This is called our basic standard solution. Okay, so we try to solve this example by using simplex method, and to do so we need to write it in the standard simplex form. These two are the equation and we are given objective function 5x plus 10y. This is our objective function. These two are our constraints. Now to do so, remember that this is our constant 8x, 8y. We have added slack equals to 160, 4x, 12y plus s2 equals to 180. and our objective function was 5x plus 10y. Now bring these two things to the left side and keep y on the left side as well. It will become 5x minus 10y plus p equals to 0. Remember one thing, if I write this equation as 5x 10y minus p equals to 0, this is mathematically correct. From this we can write this. But in case of simplex method, remember, you have to bring variables to the left side, x and y. If you have x, y, z, bring them on the left side, change, so that we want to change their signs, and keep p positive, or whatever function is z, p, keep it on the left side. I mean, keep it positive. So always write it in this form. Okay, now what we do, we write it in a matrix form, which is called a simplex tableau. Simplex tableau says first equation, first variable 8, 8. Now s1 1, there is no s2 in the first equation, there is no p in the second equation, and then 160. Similarly 4, 12, 0, 1, 0, and 180. Third equation 5, 10, 0, 0, 1, and 0. I can write it, this first equation, I can write it 8x, 8y, s1, there is no s2, there is no p, 160. Now you can see it is the same. 4x, 12y plus 0s1, s2, 0p, and 180. Similarly, the third one for minus 5x, minus 10y, 0s1, 0s2, plus p equals to 0. So when you write this system into the matrix form, it will take this form. This is called the simplex tableau form. Now here we can write it x1, x2 instead of xy. For convenience, I just write x1, x2. So this is x1, this is x2, this is s1, this is s2, and this line is for p, right? So now we define our basic variables. What are our basic variables, right? So we write our basic variables into the left hand side. You see, those variables are basic variables which have 1 in their column and rest of the elements are 0. Like x1, in x1 column we don't have 1 in the position of x1 and other elements are not 0, so this is not basic variable. Similarly, if you see x2, in x2 we don't have 1 in x2's position and rest of the elements are also not 0. But look at in s1, in s1 columns we have 1 and rest of the elements are 0. Similarly, if you see s2, in s2 we have 1 and rest of the elements are 0. Similarly, if you see p, in p we have 1 and rest of the elements are 0. So these three are our basic variables. So we write our basic variables here, s1, s2, and s3, and non-basic variables are x1 and x2. And in the previous slide I just mentioned that non-basic variables always assign value 0. Keep it in your mind. Okay, so this is our simplex tableau. Now this is our simplex tableau. This is called standard simplex tableau. Now we apply our simplex method. How do we apply our simplex method? If you see in the bottom row, if you see in the bottom row, which one is our most negative number? If you see in the bottom row, the most negative number is minus 10. The most negative number is minus 10. So this column is our pivotal column. This column is our pivotal column because in the bottom row, the maximum negative number is -10. So that is why it is pivotal column, right? Now we want to decide our pivotal row. Now with this column, look at this. Divide this 160 with 8. If you divide 160 with 8, you get 20, and divide 180 with 12. If you divide 180 with 12, you will get 15. So which one is the smallest quotient? Which one is the smallest quotient? The 15 is smaller than 20. This is smallest quotient. So this is our pivotal row. This is our pivotal row. This is pivotal column. This is pivotal row. And this is our pivotal element. This is our pivotal element. Now, since this is our pivotal element, now we will apply our simplex method. I write it here in neat form. So our x1, x2, s1, s2, p, s1, s2, p. It was 8, 8, 1, 0, 0, and 160. Then I write it again. Let's see. I change it to the new page. x1, x2, s1, s2, p, and then s1, s2, and p. It is 8, 8, 1, 0, 0, 160, 4, 12, 0, 1, 0, 180, -5, -10, 0, 0, 1, and 0. So this was our pivotal element. We have just decided that this is our pivotal element. Now we will convert this pivotal element into 1. So we will divide this complete row 2 by 12. We will divide this complete row 2 by 12. If we divide it by 12, what we will get? 8, 8, 1, 0, 0, 164 divided by 12 is 1 by 3. Here we will get 1, 0, 1 by 12, 0, and 15. This is -5, -10, 0, 0, 1, and 0. So here we have x1, x2, s1, s2, p, s1, s2, and p. Now with the help of this one, I will make 0 here and 0 here. We apply row operations as we did in chapter 4. You know that how we do this. So you apply row operations. You are quite expert in applying row operations, and you see that this is x1, x2, s1, s2, p. If you do so, it will become 16 by 3, 0, 1, -2 by 3, 0, and 40. Here you will get 1 by 3, 1, 0, 1 by 12, 0, 15, -5 by 3, 0, 0, 5 by 6, 1, and 150. Now you see that which one is our basic variable. You see that now x2 is our basic variable and s1 is our basic variable, because in x2 we have 1 and rest of the elements are 0. So here now we will write x2 and s1 will remain here and p will remain here. This is a tricky point. This is a tricky point. I explain it once again here on a separate page, what was the situation? The situation was x1, x2, s1, s2p, s1, s2, and p, and it was 8, 8, 1, 0, 0, 160, 4, 12, and 12 was our pivotal element. uh, 0, 1, 0, 180, minus 5, minus 10, 0, 0, 1, 0. The tricky point is this was our pivotal element, right? This pivotal element is coming from second column and second row. So this x2 will move to here in the second row where this pivotal row is coming from, because this is now becoming basic variable, because we write basic variables on the left side. S1 was initially basic variable, S2 was initially basic variable, P was initially basic variable. Now with the help of this 12, then we will make a 0 above and below, and we will convert this 12 into 1. So x2 will become basic variable and it will move into the pivotal row position. This was our pivotal row. So here it will become x2. Likewise here, this x2 moves to the s2 position, because now x2 is our basic variable. Is that clear? I hope it is clear now. Now again, this is the first step of simplex method. We will repeat this process again. You see in the bottom row which one is the most negative number. So only minus 5 by 3 is the negative number. So minus 5 by 3 is our now pivotal column. Now this is our pivotal column. Now again, we will divide 40 with 16 by 3. We will divide 40 with 16 by 3 and we get 7.5, and we will divide 15 with 1 by 3. 15 divided by 1 by 3, it is 45. This is the smallest quotient. So this is our pivotal row. So pivotal column and pivotal row, and this is our pivotal element. 16 by 3 is our pivotal element. We will convert 16 by 3 into 1. Now see, this x1 is in this pivotal column position. It will move into the pivotal row position. Here x1 will move here when we will convert this 16 by 3 into 1, and with the help of this one we will make 0 here and 0 here. We do this process on the next slide. So it is 16 by 3, 0, 1, minus 2 by 3, 0, 40, 1 by 3, 1, 0, 1 by 12, 0, 15, minus 5 by 3, 0, 0, 5 by 6, 1, and 1 by 50. This is our pivotal element. So this x1 will come here. This x2 is already here. So now what we will do, this is s1. With the help of this x1, we will make 16 by 3 into 1, and with the help of this, so we divide row 2 with 16 by 3. So we will get, if we divide this, what we will get 1, 0, 3 by 16, minus 1 by 8, 0, 7.5, 1 by 3, 1, 0, 1 by 12, 0, 15, minus 5 by 3, 0, 0, 5 by 6, 1, and 50. So x1, x2p, x1, x2, s1, s2, and p. Now with the help of this one, we will make 0 here and 0 here by applying row operations. So we will get 1, 0, 3 by 16, minus 1 by 8, 0, 7.5, 0, 1, minus 1 by 16, 1 by 8, 0, 12.5, 0, 0, 5 by 16, 5 by 8, 1, 162.5. So this is x1, x2, p. This is x1, x2, s1, s2, and p. Now we will see again in the bottom row, there is no negative number. In the bottom row, there is no negative number. It means that we are done with simplex method. Now we will read our solution. Now the basic variables are x1 and x2, because in x1 we have 1 and rest of the elements are 0. X2, in x2's column we have 1 and rest of the elements are 0. But you see S1, S2 are non-basic variables, and what I said, we always assign value 0 to our non-basic variables. I said beginning of the lecture, and P is also our basic variable. If S1 and S2 is 0, P is 0, so X1 is 7.5, X2 is 12.5, and profit is 162.5. So this is the maximum profit, and this is called the simplex method.